Welcome to Revised Chemistry with Mr. B. In this video we're going to be learning all about alkenes. If you haven't already seen my video on alkanes, I recommend you watch that one first, and I'll put a link up to that video now. So alkenes are also hydrocarbon molecules made from just hydrogen and carbon atoms joined together, but the difference with alkenes is they have a double bond between two of their carbon atoms. When naming molecules, remember the start of the name depends on the number of carbon atoms in the main chain. So for example, something with 5 carbon atoms in it would begin with pent. The second part of the name depends on what homologous series they belong to. So alkenes all end in -ene. So if we try and name this, we can see it's got 2 carbon atoms, so it's going to start with eth, and it's an alkene because it's got that double bond, so it's ethene. Whereas this one has got 4 carbon atoms, so it's going to begin with bute. Again, it's an alkene. We can see that with the double bond between 2 of the carbon atoms. So this one will be called butene. It's quite easy to spot which of these 2 models is the alkene. That one there's got the double bond between 2 of the carbon atoms, so that tells me it's the alkene. Whereas this one has only got single bonds between the carbon atoms, so that must be the alkane. But what if we've got 2 different bottles or 2 different beakers of these chemicals? How then can we tell which one is the alkane or which one is the alkene? This is where the bromine water test comes in handy. So bromine water is an orangey brown liquid, and we use it to tell the difference between an alkane and an alkene. So first of all, if I add some bromine water to this alkane on this side, and give it a shake, we can still see the colour of the bromine water, so it's still orangey brown. If we try the same test on an alkene over on this side, and give it a shake, we can see that the bromine water loses its colour. We say it decolorizes the bromine water. So remember, if we add bromine water to an alkane, there's no change, it stays orangey brown. If we add bromine water to an alkene, it goes colourless. When it comes to drawing the displayed formula of alkenes, it's very similar to what we did with alkanes on the last video. So first of all, if we're trying to draw the displayed formula of propene, the prop part tells me there's 3 carbon atoms in that molecule. So I'll draw those carbon atoms first. Now the ene part of the name tells me it's an alkene, so I know there's got to be a double bond between 2 of the carbon atoms. Do I put the double bond here or here? The answer is it doesn't matter. You could put it wherever you choose. So I'll choose to put the double bond there. The other bonds are single bonds. Just like with alkanes, each carbon atom makes 4 covalent bonds. So this one's making 1, 2, 3, 4. 1, 2, 3. The double bond counts as 2 bonds. So that's 1, 2, 3. We need to put another bond either above or below. Above or below, doesn't matter which. So I'll put it above. And this one's making 1, 2, 3, 4. It's a hydrocarbon, so I need to fill up the molecule with hydrogen atoms. And this would be the displayed formula of propene. Now for the molecular formula, let's see how many carbons we've got. 1, 2, 3. And the number of hydrogens is 1, 2, 3, 4, 5, 6. So the molecular formula would be C3H6. Let's do one more example. Let's choose butene. So bute tells me there's 4 carbon atoms in the main chain of the molecule. Where am I going to put the double bond? It doesn't matter. So let's put it in the middle this time. The other ones are joined together with single bonds. Then we need to make sure every carbon atom makes 4 covalent bonds. 1, 2, 3, 4. 1, 2, 3. Go below this time. 4. 1, 2, 3, 4. 1, 2, 3, 4. Then I need to put the hydrogen atoms on. So that would be the displayed formula of butene. This time the molecular formula, let's have a look, would be 1, 2, 3, 4 carbon atoms, and 1, 2, 3, 4, 5, 6, 7, 8 hydrogen atoms. So that's the molecular formula. When it comes to the ratio of carbon atoms to hydrogen atoms, we can see we've got 3 carbons, 6 hydrogens, 4 carbon atoms, 8 hydrogen atoms. So we're simply doubling it. Whatever the number of carbon atoms is, we double it to get the number of hydrogen atoms. So we could write the general formula as CnH2n. Whatever the number of carbon atoms is, we double it to get the number of hydrogen atoms. And that's the general formula for alkenes. If you found the video useful, don't forget to give it a like and make sure you subscribe so you don't miss out on future videos. Thanks for watching.